gRPC is about 80% faster than traditional REST API. So, if you want to learn how to implement gRPC as a communication channel between your Nest.js microservices, this video is for you. Hey everyone, welcome back to Sakuradev channel, and this is the episode 5 of our Nest.js microservices course. By the end of this video, you will learn how to set up a Nest.js microservice with gRPC, define and use protocol buffers files, implement a gRPC client and server in Nest.js, and also how to use NX features to automate the process of creating the types based on the proto files. So you don't need to manually create your types based on your proto files. Alright, with this introduction in mind, let's get into it. So before moving into the code, let me answer this question. Why is gRPC faster than REST APIs? First, we've got protocol buffers. Instead of using JSON, which is text-based and can get pretty bulky, gRPC uses protocol buffers. It's a binary format which makes it smaller and faster to send and receive data. So less data means faster communication. Then there is HTTP2. REST APIs usually runs on HTTP 1.1, but gRPC uses HTTP2, which allows multiplexing. Basically, you can send multiple requests over one connection at the same time without needing to start a new connection for every request. This reduces waiting time and makes things way faster. Another key difference is streaming. gRPC allows for real-time streaming where the client and server can send data back and forth continuously. REST APIs use a more traditional request response model, so there is a pause after each request while waiting for the next one. And lastly, connection management. With gRPC, a single connection is kept open for multiple requests. This reduces the need for new connections each time, which saves a lot of time. With REST API, each request often requires a new connection, which adds extra overhead. So to summarize, gRPC is faster because it uses a smaller data format, keep connections open, and can send multiple requests at once. So it is more efficient and faster. Alright, so let's get into the code. Let's keep it simple. We're going to create this simple microservices architecture with two microservices, the API gateway and product service. And the connection between these two microservices is going to be over gRPC. So here's the scenario. Here we have API gateway. An API gateway exposes a REST API for getting the product details. The client calls that API from the API gateway, and the API gateway forwards the request through the gRPC to the product service. It actually calls a gRPC named getProduct from the product service and get the product object in return over the gRPC connection. Then it returns back the product as a JSON response back to the client. So this is going to be a simple scenario that we are going to implement in this video. Alright, let's get into it. Alright, I open up the terminal here and let me quickly create a NX monorepo for our Nest.js microservices. So here I'm going to say npx create-nx-workspace at latest, and then use the preset here, so --preset, and set it to nest, which actually creates a monorepo for Nest.js project. Then we're going to provide the name here, which actually determines the name of the monorepo. I just name it Nest.js-microservices, and then provide the app name, so --app name, which actually determines the name of the first Nest.js application inside this monorepo. So I'm going to just name it API gateway. Okay, so let's run this command. So would you like to create a Docker file? I'm going to say yes, and use the jest for testing, and also ESLint, prettier, and choose the GitHub Actions for CI. Let's wait for it to create the monorepo. Alright, it's done, and now let's open it up in VS Code. So first let me navigate to the Nest.js microservice directory. Okay, now let's open it up in the VS Code. Alright, so this is our monorepo, and as you can see there is an apps directory here, and inside it we have an API gateway project. It's a Nest.js application, and as you can see it runs on the port 3000. So now let me quickly create the second Nest.js project, which is going to be products microservice. So I open up the terminal here, and since we have used the Nest preset for this monorepo, we don't need to add the Nest.js plugin here. It is already added by the Nest preset. So now let me use this plugin to generate another Nest.js application. So I'm going to say nxg and then name of the plugin, which is nx/nest, then colon name of the generator, which is going to be app. That means that we are going to create an entire Nest.js application. Then we're going to put the path and name of the Nest.js project. So I'm going to put it inside the apps directory, and then its name is going to be products. Okay, so let's run this script, use the ESLint and Jest for testing, and it immediately creates the second Nest.js application for us. So now you can see the products application and also the products E2E, which is for creating the end-to-end test for the products project. All right, so now let's set up the gRPC server inside the products microservice. So first, let me install the packages. Let me clear this up first. I'm going to say npm I. The first package is going to be at Nest.js/microservices. Okay, so let's run that, and we've got an error, and that's because the Nest.js microservices requires the Nest.js version 11, but the NX preset installed the Nest.js version 10. All right, so in order to fix this error, we need to upgrade our Nest.js packages to the version 11. So in order to do that, we need to uninstall the Nest.js packages and then reinstall them with the latest version. So here I'm going to say npm uninstall at Nest.js/common at Nest.js/core at Nest.js/platform express, and finally at Nest.js/testing. All right, so let's uninstall these 4 packages, okay, and then install them with the latest version. So first we need to use the npm I and then put the @latest for each of these packages. Okay, and then run them. Okay, we're good to go, and now we can install the Nest.js microservices package. So npm I at Nest.js/microservices. Okay, so as you can see, the error is gone, and we can install the microservices package with this Nest.js monorepo. We also need to install 2 more packages here for gRPC. So let me clear this up, and let's install them. npm I. The first one is at gRPC/gRPC-js, which is the package for establishing a gRPC connection between the client and server, and also install the at gRPC/proto-loader, which allows us to create the proto files for our gRPC connection. I'm going to show you how we can do that later in this video. So let's install these 2 packages. All right, it's done. And now in the next step, we need to create a proto file which defines the schema of our gRPC connection. All right, in this section, we're going to create the proto file for our gRPC connection, which actually is the heart of the gRPC. This file is what defines our service, requests, and responses in gRPC. It's kind of like an API contract that both client and server agree on. All right, so let's create the proto file from the scratch and explain everything as we go. So since this proto file is shared between the server and the client, I'm going to put it inside the root of our monorepo. So outside the apps directory and in the root of our workspace, I'm going to create a new directory here. I'm going to call it proto, and then inside it, I'm going to create a proto file named products.proto. So first we need to specify the syntax version. So I'm going to set the syntax to proto3. This tells the gRPC that we are going to use the protocol buffer version 3, which is the latest and most commonly used version. Next, we need to define the package name. So I'm going to say package and put the package name here, for example, products. This is like a namespace in programming. It helps organize our code and prevent conflicts if we have multiple proto files. Then we need to define our service. So I'm going to say service and name the service to product service. So it's like an API controller in REST setup. And inside this service, we're going to define our remote procedure call, or RPC. So in order to do that, I'm going to use RPC keyword here and then put the name of the RPC. So I'm going to name it get product. And this takes a product request. I'm going to specify product request here, and it returns a product response. So I'm going to use returns keyword, and then inside the parentheses, I'm going to specify product response. And finally, put a semicolon here. So this RPC takes the product request as its input and return a product response. As I said, this is actually similar to defining a REST endpoint, but instead of HTTP routes, we're defining functions that the client can call. Now we need to define the structure of our product request and also product response. So here, in order to do that, I'm going to use message keyword here and then put the name of product request. And then inside it, we need to define its structure. It contains a single field, which is product ID, which is going to be a 32-bit integer. So in order to define the types here, we need to put the types before the field name. And finally, we need to put a field number here. So I put the 1 as the field number here, which helps gRPC efficiently encode and decode the data. So this is the structure of the product request. And now we need to define the structure of the product response. So in the same way, let's define the product response. I use message keyword here and then define the product response here. It is going to be like an object. It has product ID inside it. So int32 product ID and the field number is 1. Next, we have the string name. The field number is 2 here. Actually, we need to put the semicolon after each field. Let me fix that. Okay. And finally, we have a int32 price of the product and set the field number to 3. And that's it. This is our proto file here, which defines everything the client and server need to communicate in a structured and efficient way. In the next step, we need to generate the TypeScript types and use them inside the Nest.js project. So before moving forward, let me just turn the first letter of the product request to uppercase and fix it here. Although it's not necessary, but let me just do it in order to have a cleaner code. Alright, so as I said, in the next step, we need to create the TypeScript types based on this proto file. Alright, so let's create the TypeScript code based on this proto file. But we're not going to do this manually. Instead, we are going to use a tool named TSProto to automatically do this for us. Okay, so in order to do that, I'm going to install the TSProto here. So I'm going to say npm I TSProto. Alright, it's done. And now we can use it to generate the TypeScript code that required in Nest.js to implement the gRPC. Alright, in order to do that, I'm going to say npx proto-c and then --ts underscore proto underscore out, which actually determines where we are going to create the types file. We're going to put them inside the root path of our monorepo inside a types directory. Okay, and then we need to feed the proto files here. So they are in the proto directory inside the root path of our application. And then inside it, I'm going to use wildcard.proto, which means that we are going to feed every proto file inside the proto directory. And finally, since we are going to generate these types file exactly for Nest.js, we're going to set another parameter here, --ts underscore proto underscore opt, and set it to Nest.js equals to true. Let me close the Explorer here. You can see the whole script here for creating the TypeScript code for Nest.js. And pay attention to the spelling here, especially with this Nest.js here. Okay, so let's run this command. We've got an error, and that's because we don't have the types directory inside our workspace. So let me quickly create the types directory in the root path of our monorepo. Okay, so this is the types directory. So let me close this up. And let's run the previous command. Okay, so it's done. And if I go to the types directory, you can see we have a products.ts file, which corresponds to this products.proto file. Okay, so let's check inside it. It contains the necessary TypeScript codes for implementing the gRPC both in the server and in the client. Okay, so we don't want to actually go through this file, but I want to show you how you can use these TypeScript codes to streamline the process of implementing the gRPC both in the server and in the client. So for now, let's close this off. Later in this video, we are going to configure the NX to automatically generate the product.ts file every time the profiles are changed. But for now, let's just use the generated TypeScript codes here to implement our gRPC server. Alright, so let's do that. First, I go to the products microservice here and go to the main.ts file, and here we need to create a microservice that use the gRPC as its communication channel. Okay, so let me just remove these codes here, and then here, instead of this create function, we're going to use create microservice and then put the microservice options type here in the generics, then put the app module. Let me close the Explorer here. So I put app module here and then put the option object inside it. First, we need to define the transport. I'm going to set it to transport.grpc. make sure to import it from the Nest.js/microservices. Then we need to put the options here, and then inside it, first we need to provide the package, which should be the same as this products here, because here we define the package as the products. So in order to do that, you don't need to hard code it. It is actually present in the product.ts file, which we have generated with the TS-Proto. So let me just use that constant that is inside the product.ts file. So here, as you can see, we have a constant here, product package name, which is set to products, which actually equals to this package products here. Okay, so we can use that products package name, which is imported from the products file inside the types directory. And then we need to provide the path for the proto file. So I'm going to define a proto path here, and we're going to use the join function, which comes from the Node.js. Okay, and then here we're going to use underscore dir name, which is the current directory, and then put the address of our proto file, which is going to be inside the proto directory, and then products.proto. This file should be inside the dist directory, which actually contains the built version of our Nest.js application. I'm going to show you how you can include these proto files inside the dist directory. All right, we're done with the create microservice here. And finally, we need to use the await app.listen. Okay, we don't need to provide any ports here because this microservice doesn't listen for HTTP REST endpoint. Although we can have a hybrid application that can listen for multiple communication channels. You have seen how we can do that in the previous episode of this course. Okay, and finally, let me just change the log here. We're going to say application is running on gRPC channel. Okay, now let's run the application. So use nx run mini, then -t to provide the target name, which is serve, and then --o, which actually runs all the application inside this monorepo. So the API gateway is listening on the port 3000, and here we have an error with the products microservice, which complaining about the products.proto file, which it couldn't find it inside the dist directory. So here, as you can see, we have a dist directory which contains the built version of our Nest.js application. So here we can see inside the products, we do not have any proto directory and proto file inside it. So now I'm going to show you how we can include the proto files inside the dist directory. Alright, so now let's make sure that our proto files are included inside the dist directory when we build our project. In order to do that, we need to go to the nx.json file, and inside this file, we need to define some default options for our build target. So at the end of this JSON file, we need to define the target defaults, which, as I said, defines the default options for specific targets like build, test, and serve. In this case, we are going to define some default options for our build target. So we need to define the build here, and inside the build, we need to put the options here, and inside the options, we need to put the assets. The assets option here specifies the extra files that need to be copied into the build output directory, dist directory. Okay, so here we're going to set it to a list here, and then inside this list, we're going to define an object. Inside this object, we're going to use the globe here, which actually determines which files should be processed or included. It's actually a pattern matching syntax to specify which files should be included. So we're going to specify the pattern here, which is all proto files. So wildcard.proto. Then we need to define where we should use this pattern to find the proto files. In order to do that, we need to specify the input. So we're going to say use this pattern inside the proto directory, and then we need to specify where we should put the proto files inside the dist directory. In order to do that, we need to specify the output, and then we're going to put them inside the proto directory in the dist directory. So with this code here, we say that for the build target, copy all the proto files inside the proto directory in the root of our workspace to the proto directory inside the dist directory of each project. So let's save this, and let's open up the terminal, and let's run the application again. All right, the API gateway application is listening on the port 3000, and the products application is running on gRPC channel without any error. So if I go to the dist directory and then go to the products directory, you can see we have a proto directory, and inside it we have the proto file. So now our products microservice is running on the gRPC channel without an error. Next up, we need to define the get products RPC, which we have specified here in the products.proto file. Right, so let's do this. First, we need to create a controller inside the products microservice and then define the RPC inside it. So in order to do that, I'm going to use the NX generator to create a controller for the products microservice. Let me turn off the dev server, and then I'm going to say NXG, put the name of the plugin, which is NX/nest, put the name of the generator, which is controller. So we're going to say that we're going to create a Nest.js controller. I'm going to put it inside the apps directory, and then products, and then inside it, I'm going to put it inside the src, and then app directory, and then name it product. Okay, so let's run this generator. As you can see, it creates the controller. So let me open up the app directory inside the products microservice. You can see we have a product controller inside the app module. Okay, so let's open it up. And I think we have a typo here. So first, let me get rid of the test file and then rename the controller. Okay, also fix it here and also here. All right, we're good to go. This controller actually is not going to be a REST API controller. Instead, we are going to use it for gRPC. So I'm going to use another decorator product service controller method. And this is coming from the types file that we have created with the TS-Proto. Okay, so in this way, we are going to tell the Nest.js that every method inside this class is going to be a RPC. So then here, I'm going to use another interface from the products.ts file. So I'm going to say this product controller implements product service controller. Okay, so as you can see, again, it comes from the products.ts file. Now we need to define the get product here. So if I hit the control space, we have the get products here. That's because this class implements the product service controller. So as you can see, we have the request, which its type is going to be product request. So if I click on it, you can see inside it, it's a interface that inside it, we should have a product ID, which is going to be number, and it's based on this product request here. All right, next, we need to return a product response. So if I click on the product response, you can see it's a interface that should contains product ID, name, and price, which is exactly based on this product response here in the Proto file. So you can see TS-Proto is a very excellent tool that automates the process of creating these types and decorators for Nest.js. Okay, later in this video, I'm going to show you how I can create a task for calling the TS-Proto to create the types code whenever this file is changed in our application. But for now, let me just focus on this get product RPC. So here inside this get product function, we're going to just return a dummy product. So I'm going to return an object. It should contain a product ID. It is going to be, for example, 12, and it should have a name. For example, I'm going to say something like laptop, and a price that, for example, is 1,000. Okay, so we just returned this dummy product as a response of this RPC. And here I think I don't need to waste your time configuring the Prisma for fetching a product from the database. I think you all know how you can configure the Prisma. So we just return a dummy product as the response of this get product RPC. Okay, so we're done here and we have an error here. That's because we renamed the product controller. So we need to rename it here inside the controller section of the app module. All right, so we're done with the gRPC server. And all we need to do here, we need to set up a gRPC client inside the API gateway. So with that gRPC client, we can call this get product RPC from the products microservice. All right, so now let's set up the gRPC client inside the API gateway microservice. So I go to the apps directory inside the API gateway, and I go to the app module here. And in the import section, we need to register the gRPC client. So I use client module, which comes from the Nest.js/microservices, and then call the register function. And inside it, we need to pass a list and here we need to define our microservices clients. So here we need to configure our gRPC client. First, we need to provide a name for it. And for the name here, we need to use the name of the package. So instead of hard coding this, we are going to use the product package name, which comes from the products.ts file, the types file actually, that is generated by the TS-Proto, and then specify the transport. So it is going to be transport.grpc. Okay. Next, we need to provide the options. And inside the options, first we need to specify the package name. Again, we're going to use this constant here. And then we need to specify the path of our proto file. So I'm going to set the proto path here and set it to join function from the path package of the Node.js, and then put the current directory __ dir name, and then proto.products.proto file. We already have configured the NX to put the proto file inside the dist directory for each application. So here, let me open up the API gateway inside the dist. We can see the proto directory and products.proto is also inside the API gateway application. Okay, so that's it for defining the gRPC client, and now we can easily use it inside the controllers. So we're going to generate another controller here. I open up the terminal and use NX generators, NXG, name of the package, which is nx/nest, name of the generator, which is controller, and put it inside the apps directory, and then API gateway src/app, and then put it inside the product directory, and then name of the controller, which is going to be product. Okay, so let's run this script. It creates the product directory here and put the product controller inside it. Okay, so here we just need to inject the gRPC client. So in order to do that, inside the constructor, we're going to use @inject, which comes from the nestes/common, and then put the name that we have defined here in the app module of this API gateway application. We need to put this name here. Okay, so let's get back here to the product controller of the API gateway. Don't confuse it with the product controller inside the product microservice. That was for the server, and this is for the client. Okay, so I use product package name, and then we're going to inject it using private client, which is going to be client gRPC. And this client gRPC comes from the nestes/microservices. Okay, now inside this product controller, we need to define a product service. So private product service, which its type is going to be of type product service client. That comes also from the products.ts file inside the types directory. Okay, now we need to use on module init function and then initialize this product service using the gRPC client. Okay, so I'm going to say this product controller implements on module init. So we need to define the on module init function, and inside it, we're going to say this dot product service, which we have defined here, equals to this dot client, which is our gRPC client, dot get service, specify the generics here, which is going to be this interface, product service client, and then we need to put the service name here. So it should be this service exactly of this name here, product service. So again, instead of hard coding this, we are going to use the product.ts file inside the types directory. So I use the product service name. Okay, if I open it, you can see it is the product service, which is exactly the same as the product service here in the proto file. So you can see how this TS-Proto simplifies implementing the gRPC. That's it. We have initialized our gRPC client. Now we can use it inside this controller. So let me expose a get endpoint in the API gateway, so the client can call this using HTTP request. And let's define a find one function. And then inside it, we can just call the RPC from the product service with this product service here. So we can just return this product service get product, which is our RPC. Now, if I go to the proto file, you can see it takes the product request, and the product request contains a product ID. So we need to put the product ID inside it. You can see, thanks to the product service client types, we have all the types and autocomplete here. So for example, let me put the 12 here, and actually returns the product response out of this get product. Also, let me import the get decorator from the nested/common. And also here, we can just take this product ID from the CRAMS or search queries here. We all know how we can do it, so I don't want to waste your time here. Just let me hardcode it inside the product request here. All right, now let's open up the terminal and run the application. The products application is running in the gRPC channel and the API gateway is listening on the port 3000. Okay, so let's open up the Insomnia or Postman to call this get endpoint here, which actually calls the get product RPC. All right, so here we're going to send a get request to the localhost 3000 and then API and then product. Okay, so let me send this request. You can see immediately get the response. Product ID 12, the name is laptop, and the price is 1000, which is exactly of this object that we have returned here from this get product RPC. So as you can see, the API gateway can successfully call the RPC from the product service. All right, so let me do a recap here, and then after that, I'm going to show you how you can create a task for the TS Proto to generate the types whenever the proto files are changed. All right, let me do the recap here. First, we need to write our proto file. So I create a proto directory and create the products.proto file, which is here. And then with the TS Proto, we automatically generate the types and interfaces and also the decorators that are required to implement the gRPC in the server. Then we're going to go to the products microservice, which is our gRPC microservice. We create a controller here and then decorate it with the product service controller method, which comes from the product.ts file that is generated with the TS Proto. Then we're going to implement the product service controller. Again, it comes from the product.ts file, and then define the get product method, which is actually our RPC. It takes the product request and it returns a product response. Then we go to the API gateway and configure our gRPC client. So inside the app module, we use the client module.register, specify the name of the client here, and then specify the transport.grpc. Is very important. If you don't specify this client send the request through the TCP channel. We don't want to do that, so make sure to set the transport to transport.grpc. Next, we need to define the package name. Instead of hardcoding that, we get that from the product package name constant from the product.ts file, and then specify the path of the proto file. Also, make sure to configure the NX here so that our proto file are copied to the proto directory inside the this directory. Then I've created a controller inside the API gateway that uses the gRPC client. We created a product service client and then inject the gRPC client. And with that gRPC client, we initialize this product service inside the on module init and then simply call the get product RPC from this product service here. That's it. We have implemented a gRPC connection between the API gateway and products microservice. Alright, so now let me show you how you can automate creating the TypeScript codes and types with a NX target. So it automatically creates the types with the TS Proto whenever our proto files are changed. So in order to do that, I go to the package.json inside the root path of our monorepo. And here inside the script, we're going to create a script and I'm going to name it something like generate-proto-types. And then set it to the exact command that we have executed to generate the types file with the proto-c, which comes from the TS Proto package. Okay. Then we need to create a NX target here inside this package.json file. So NX, and then we need to put the targets here. And inside the targets, we should put exactly this script here and then set it to an object here. We're going to use the cache here. So we're going to set cache to true. And since we are going to use the cache, we need to specify the inputs here. So with the inputs, we specify the file that the NX should watch for. If the files that we have specified inside the inputs are changed since the last time we run this generate prototypes, it actually will run this script again. If the file that we are going to specify here doesn't change from the last time we run this command, it actually hit the cache and doesn't run this script again. So it actually leverages the cache here and makes the build process faster. Alright, so here we need to specify the path of our proto files. So I use workspace root variable here, which actually point to the root path of our workspace. Then inside it, from the root path, we need to look inside the proto directory and all the proto file inside it. Alright, so with this command, we can leverage the cache with this target. Now, in order to run this target, we can simply run nx and put the name of the target, which is generate prototypes. So you can see it runs this command, which we have used to generate the types file. Now, if I run it again, you can see it read the output from the cache instead of running the command because the proto file has not been changed. So if I go to the proto file here and change the file a bit here, for example, rename this product ID to product ID 2, save this and run the nx generate prototypes. You can see it runs this script from scratch because the file has changed. So now let me get it back to the product ID here in the proto file and let's run the generate prototype. Alright, so we have created a target for generating the types with the TS proto. Now we need to go to the project.json file inside the products microservice, and here for the build target here, we need to specify the depends on and specify the generate prototypes target. So every time we run the build command, we first run the generate prototypes target. So first, let me define that target here in this file. So at the end of the file, we need to define another target here. I'm going to just name it the same name, generate prototypes. And inside it, we need to specify the command and set it to nx generate prototypes that we have defined in the package.json file in the root path of our monorepo. Let's get back to the project.json file of the product microservice. Now we have this target here. So we only need to go to the build target here and specify the depends on and specify the generate prototypes here. Okay, so every time we run this build command, we first run this target. All right, now let's run the application, which runs the build command. So as you can see, it does not run the generate prototypes here. I think that's because we need to put it inside this targets object because here we have put it after that. So let me cut that here and put it in the targets object. Let's save this. And as you can see here, first it runs the tsproto command when we build the project. And if I run the application again, you can see it hits the cache here because the proto file has not been changed from the last running. So now let me do a recap here again. First, we go to the package.json and create a script for running the tsproto command. Then we need to define a target for this and specify the cache and inputs for watching the file change to decide whether it should use the cache or run the command from scratch again. Then I go to the project.json file inside the products microservice. We create the same target inside the targets object, and then we find the build target and simply specify the depends on and put the generate prototypes that we have defined here at the end of this target object. So every time we build the application, first we run the generate prototypes target. So yeah, that's it for implementing the gRPC between our microservices, and we have seen how we can leverage the features of NX to automate the process of creating the types based on the profiles in our monorepo. I put the link to the GitHub repo of this application. You can check it out. If you use that repo, please give it a star. As you know, I'm a freelancer and my GitHub stars creates my credibility. It doesn't cost you anything, but helps me to build my credibility. Also, if this video was helpful for you, please hit the like button and subscribe to the channel for more videos on this course, Nest.js Microservices course. Thanks for watching. Stay tuned for the next episode of this course, which is going to be on implementing Kafka as a communication channel between the Nest.js microservices. All right, have a nice time. Bye-bye.